This is vvvvTv.
And this is Randall Vasquez, the voice of vvvvTv.
Hello, it's a pleasure to be here.
Here with me today because we're talking about OpenCV, the library that Randall initially wrapped for vvvv. So please, Randall, tell us what is the CV in OpenCV?
Of course. So the OpenCV in the CV in OpenCV stands for computer vision, and that basically means making your computer understand images. So we're talking about everything from image processing, which includes filtering, for example, everything calibration, detection, recognition, tracking.
Yes. So it's quite a vast range of topics that the library covers.
Absolutely. Yeah.
Thinking maybe we just look at the Node browser. Operator, can we get the screen? So we're assuming people have installed the library, but maybe briefly show the
Absolutely. So
NuGet source.
So if you go to nuget.org and search for VL.OpenCV, you will find our documentation page here. And yes, this is what we're working with at the moment. Yep.
Maybe hide the browser again. So
all right.
So if we look in the Node browser, how does the library present itself?
Right. So first of all, we find the OpenCV category right here. And if we click on it, we can see, let me get rid of the advanced nodes over there. We can see our general categories. No? For example, the first thing you would want is to take an image from somewhere. So a source would be the right place to look. And once you have an image, you can start working with it. For example, filtering it, or tracking something in your image, or detecting something in your image, or potentially even doing some sort of utilitarian work on it as well. Yeah. And finally, you want to get your image out somewhere, and for that you have your syncs. Yeah.
Okay, and then I see drawing and calibration you haven't mentioned.
Yeah, true. So drawing is a bit of like a debug helper type of node set that will help you visualize the things you're detecting or tracking in your image. It's built for those purposes. And calibration is regarding everything: camera calibration, projector calibration, intrinsics, extrinsics. And
bit of an advanced topic we're not going to cover today. So really we want this episode to be an introduction to working with OpenCV in vvvv. And so we will mostly cover like input sources, applying filters, and how to get the CvImage back out into your application.
Exactly.
Right? First thing, we have a camera here, simple webcam, and we want to get that image to apply some filters on it. So
let's dig right into it. So first of all, again, we go to our sources. You can see we have quite a few options in there. I'm just going to go with video in for today. Here we have our node, and if I create a little tooltip right here, you can already see that, yep, we're here. So we already get something out of it. And so our video node comes with a few options here. For example, a list of devices you can select from, preferred size, preferred FPS.
Why preferred?
Good question. Well, here you see a video device supports only certain configurations and not everything. So I could type some weird, number here, and that might not be a correct configuration for my device. And so how do we know, no? How do we know what my device can do, and how do I know what I'm actually getting? So first of all, here's a list in this output pin. We give you a list of every single configuration, resolution, FPS, and whatnot that this current device supports for you to have as reference. And we always have the info node over here, which will also give you more basic information like the size, the amount of channels, and the type of image you're looking at.
So in this case, we see, we asked for 1024, but we got 960 because the device just can't handle.
It doesn't have a 1024 configuration.
Yeah.
Right? Exactly.
Okay.
So let's go back to our standard here, just for clarity.
So it should, yes, adapt itself back to that. So now that we have, so that is for these cheap webcam type devices. But what if I have a device here, like a more professional industrial input camera capture device? how would I get these into CV land?
Absolutely. So yeah, there are these specialized cameras out there, and usually they come with their own libraries because you want to tap into special features that they support. And so this one is
the imaging source device.
all right. So we have a package just for that. So I'm going to now reference this package, and what that means is that I can now type video in, and I should have now a new type of video in, which is specifically this device. And now, as you see, if I try to connect it to my CvImage workflow, it doesn't work. So how do I get it into the CvImage land, where there's something called the video source format, we could say, and we have a special node going from video source to CvImage. So I can connect my video in there, and I can connect my video source here, and you can see that we're already seeing something.
This camera. Okay.
Yes. It's a bit of a grainy camera, but that's not what we're here for today.
Okay, so some cameras I might be able to get into CV land using this particular node. I remember it's also the NDI node set that you can
support. Yeah, they supports the same format.
Yeah.
Yes.
But next, there are also devices that return a texture instead of an image. And also, you might just have a texture generated in your app that you want to analyze.
Absolutely. I could be in Stride, for example, and doing some stuff there, and I want to do some image computer vision task on it.
So how could you get a texture into CV land?
All right. So let's start with getting textures in our patch first. And for that, I'm going to quickly reference the Stride texture effects package, just so we get something. Yeah.
Example.
Do you have any idea of what we could?
Neurons.
Neurons is a good old favorite. Let's go with that one. So here you can see I have this texture, and then to go into CV land, we have an texture to image node, right? That I can connect down there, but it's not. Oh no, sorry, I cannot connect this just yet.
You connected.
I can connect the neurons to this guy, and now I have an image, but that's still not compatible. And for that, in OpenCV, we have the from image node, which
and maybe show that you can reach it from the source category.
Absolutely. So here we go, source from image. And this one I can connect to my texture to image, and I can connect it to my tooltip. But
something is off with
something's a little different, isn't it? Well, it turns out that OpenCV uses a different channel order for the color channels in images. And so we need to make sure we go, for example, in Stride, it's actually using RGBA, and in OpenCV, we're using BGRA. So here we have a special pin in the texture to image node that allows me to specify the channel format, like the order, the amounts of channels, and so on. So let me just find the BGRAA, there we go. And that looks about right to me.
Yeah.
Okay.
Okay, so we have video in, we have the special type sources that we pipe into CvImage, and then we have the texture to CvImage. And then what about if I have not a live source, but I have a video on disk that I want to play and analyze maybe?
Absolutely. That is a fairly standard use case as well. And there you have two options. Either you want to deal with your video in real time, or you want to process it as fast as you can, as fast as your main loop and your CPU can handle it. So for the first example, you're probably already using the VL video package, which I'm going to quickly reference here. And there you have a video player node that connects also to this video source CvImage thing. So we're already in CV world there. Yeah. And in the case where you want to do the offline or non-real-time processing.
What would be, what's the use case there?
Yeah, of course, you want to do some processing. Let's say you want to detect some phases or blur your video or something like this, and you want to do it as quickly as possible, and you don't want to look at it. And
it's not about the real-time.
It's not about media playback. And then what you would use is the OpenCV native video reader node, which is already outputting a CvImage, so it already connects to our workflow.
Okay, so I think this gives us quite a few options now ready to come into the CvImage territory. Well, how about we clean this patch a bit and now see how we can apply some filters here.
Yeah, so let me just get rid of this unnecessary thing.
So applying a filter, what are we talking about? A blur.
All right, let's start with a blur. So, well, maybe let's do it more cleanly. We have the OpenCV filter category, and there, as you can see, there's plenty of filters. So let's start with a blur. It has some configurable pins, and as you can see, my image is getting quite blurry now.
Cool. We said like a threshold, maybe?
Sure, threshold, but yeah, let's just try it. And the output now is a bit weird because usually when you're dealing with threshold, what you want to do is you want to have a one-channel image. This is looking a bit funny because here we have 3 channels and we're thresholding all of them. So I'm just going to add a node that helps us go from multi-channel image to a single channel image called grayscale. And as you can see now, this threshold is a bit crazy. Let me bring this a little bit down. Maybe even I can take the blur out and you can see more or less what this threshold is doing. And in this case, since we have this kind of black and white image, I can somehow cut it off more or less based on brightness, no? And this could be helpful in certain workflows.
Okay.
All right.
You briefly mentioned you can take out the blur. Can we?
Yes, absolutely. So the nice thing about filters is that they're chainable, meaning you can put one after the other and create more complex effect combinations with them. But of course, all of the nodes come with an apply node that you can just turn on and off. So you could potentially even have some logic that enables and disables them at certain moments in time or something like this. Yeah.
Can you show the help browser, the node browser again with a long list of filters? So this is really a rather extensive list. Some of them, if you have a help text, but then some of them really have a large number of arguments.
Potentially weird name like Sigma color, Sigma space, D.
How would I find out about what they are doing?
Yes,
is there any chance?
We tried again to have help text on the nodes and the pins wherever we managed to get it there. But if you still want more information, you can always go in our NuGet page. We have a link to the specific OpenCV version we're using under the hood, and that will link you directly to the OpenCV specific documentation.
Official OpenCV documentation.
Exactly. And here you can try and find the node you're working with. Usually there's an equivalent function with the same name, and there you can really see exactly what each input is doing, what is the expected values, and so on.
Yeah. But I guess key here is that OpenCV comes in many versions, as you can see here, and to know which version of OpenCV we are talking about, you go here and you see the version of the package you're currently using.
Yeah, hopefully in the future we will keep on updating this, and right now it's 4.9, but later it might be a different one. So this is how you know, right there.
Okay, I think video input, filters, what next? Output, I'm happy with my results, but I have some display in my final app that I want to pipe out some images from CV to my Skia app or Stride app.
Absolutely, and that's where our OpenCV syncs come in. No? And as you can see, we have a few of them. Of course, we have a render that gives you a window to work in while you're in OpenCV world. You could write your image out to a file. But in this case, let's say we want to go back to Stride, for example. We can use the toImage node. And how it works, I connect my original CvImage to my toImage node. And here, let's say I want to go to textures. So it's image to texture. I need to reference Stride, of course, because I'm going to be doing some Stride work. And now I should be able to find my image to texture. But before I connect it, I'm going to make a note of, as the note well explains, OpenCV doesn't really know about the format of the image. But when we're doing conversions, knowing the format is important. So we, as the user, need to make sure that the image we're passing down to our next pipeline or workflow or technology is going in the right format. And for that, the CvImage gives us this input pin here, which is pixel format. And since we now have a one-channel image...
How do we know that we now have a one-channel image?
Well, there's a few ways. The tooltip here says this C1 means one channel. And also the info node here gives you this channels output count. So we have a one-channel image. The one-channel image format is the R8 image format. And now if I connect this here, you can see that my image is now in stride space. And it looks red because it's going to the single channel
texture has just the red channel that we are seeing. Okay. And the same applies to if you want to go to Skia, you have in Skia, I believe,
image to SkImage, I believe it's called.
Or is it just from image, Skia? You will figure out. There is an
equivalent node to this.
Equivalent node,
yes.
Exactly. Okay, I think we are close to what we wanted to show. Finally, so far we've only shown very light image processing tasks, but when it comes to computer vision, we know that some of these tasks are really CPU heavy.
Yes.
And let's maybe just draft one of these cases.
Absolutely.
Here. I think we can get rid of most of this. No?
Clean up. Yes. I mean, even the filters here and even this guy we don't need. So start again, just our video in. And a typical heavy task is, for example, the optical flow. Yeah. And of course, in these days with all the 4K textures and stuff, you could rather quickly find yourself with a heavy workflow. You can see here already,
in the tooltip it shows
quite heavy, yes. And just to give us some sense of performance, I'm gonna give us a scene window so we can look at this nice perf meter we have over there. So let me just get this guy over here and press F2. And here you can already see we've gone all the way down to, well, first of all, let me remove this. We're all the way down to 9. No?
And that's just the optical flow.
That's just the optical flow. To understand what the optical flow is doing, I'm going to use one of these draw nodes we mentioned briefly before that lets us see more or less what it's doing. So you can see now when I move, I have this trail that somehow knows which way.
A vector of movement, no?
Exactly. Yeah. What we're focusing now is on the performance issue. And of course, you don't want your patch running this slowly. So how do we make it go back to a snappy 60 FPS, hopefully? Well, for that, we have something called the async loop region. And this guy here, we can just drag and drop our optical flow heavy processing into. And well, I can connect this here now. And you see our FPS is back up to 60.
It's working again, but it's 60 FPS. So how? Why? What happened?
Well, it's a bit technical. We're sending it to a different thread. So it might mean if you have a multi-core computer, it's now being handled by a separate core, or it could be just being handled in a separate thread in the same core. But in the end, it's somehow in the background.
It's outsourced, and it's not blocking your main application anymore.
Exactly. And a little detail that I think we should bring up is that even though we managed to connect this here, this is actually not a CvImage, but an observable of CvImage. And the right way to actually get back into OpenCV world would be to use a whole latest copy if you have an observable of CvImage. And now you're actually back on the CvImage pipeline.
Yeah.
Yeah.
Okay. I think that covers like the most basic things that you need to know. I would say anything further from here, we just show the people the help browser.
Yeah, let me just get rid of this. So we've prepared plenty of help patches, ranging from the basics to topics like calibration, detection, drawing, filtering, tracking, batch processing, and other more utilitarian workflows. So you should be able to find a starting point in whatever task it is you're attempting to achieve in the OpenCV workflow.
And if you hit any roadblocks there, you know where to ask. You can ask a question right down there in the video comments, or you come to our forum or the chat, and we will try to help you out there. But that will be it for this episode.
I think that's a wrap, yes.
Anything? All good from the operator? Final words?
See you on the next one, I guess. And enjoy your CV adventures. Ciao.
See you.